We are now going to do two examples in which we're going to rationalize the denominators. And by rationalizing the denominators, what we're going to do is make sure that the denominators do not include a radical expression. In our first example, we see that we have the square root of 10 in the denominator, and we don't want that. So, and this is one of the simplest cases that we can have. And what we're going to do is we're just going to multiply the top and the bottom by that square root. And we can multiply by the 3 square root of 10 if we wanted to, but we really just need to multiply it by the square root of 10 to get rid of that square root. So let's go ahead. I'm going to just switch this over to my stylus. See if it cooperates. There we go. So I'm just going to rewrite this. 2 times the square root of 3 over 3 times the square root of 10. We're going to multiply both the top and bottom by the square root of 10. And remember, we can multiply both the numerator and the denominator by whatever we want, as long as we multiply both by the same value. And radical 10 over radical 10 is the same as 1, so this is fine. We're keeping everything the same. When we do that, we'll get the radical 3, 2 radical 3, radical 10 in our numerator. And on the bottom, in the denominator, we're going to get 3. And then the radical 10 times the radical 10. So we have the square root of something times the square root of something. Well, the square roots cancel out. So we're going to square. We're squaring a square root. They're inverse functions. They cancel out. So we'll be left with just the 10. So this is perfect. So now we no longer have a radical in our denominator. Now I'm just going to simplify. So we can simplify this by rewriting this as 2. I can combine the two. I'm multiplying two radicals. I can combine these two numbers by multiplying them together. So 2 radical 30 over, and 3 times 10 is 30. To put it in the simplest form, I notice that this is an even number and this is an even number. So these two I can simplify to 1 over 15. So it's really the radical 30 over 15. And this is as simple as I can make it. So I'll leave it right here. It's my final answer. Now, our second example, we have not just a simple radical in the denominator. In the denominator, we have a number, a non-radical, being added to a radical. In a situation like this, what we need to do is multiply both the top and the bottom by the conjugate. And to get the conjugate, what we do is we'll rewrite this expression and we'll change the positive or the addition sign to a subtraction sign. Had it been a subtraction sign, we would just reverse it and change it to an addition sign. So let me rewrite this. So we have 4 over 1 plus the square root of 5. And we're going to multiply both the top and the bottom by the conjugate. So in this case, it will be 1. We're going to change the sign to minus square root of 5. So we're going to multiply by that on the bottom. And we're going to do the same thing on the top. I'm just putting all of this in the parentheses to make it clearer when we carry out our final multiplication. So just as before, we're going to multiply the numerator, right? Numerator by numerator. So we'll have on the numerator 4 times 1 minus the square root of 5. We still have to simplify that. On the denominator, well, we're multiplying two binomials essentially. So remember, whenever we do that, we take the first value, we multiply it by everything in the second parentheses, and then we take the second value and we multiply it by everything in the second parentheses. So let's do that. So 1 times 1 is 1. 1 times negative square root of 5 is negative square root of 5. Square root of 5 times 1 is positive square root of 5. Square root of 5 times square root of 5, well, we're multiplying, or we're squaring essentially two square roots. The square root's going to cancel out, so we're going to have 5, but it's minus, so it's minus 5. Okay, so now we're going to simplify this even more. So here we can distribute our 4s. We can leave it alone if we want as well. Doesn't matter, but I'll go ahead and distribute my 4. So 4, right, 4 times 1 is 4. 4 times negative square root of 5 is negative square root of 5. And And our denominator, let's see, we have a 1, the negative square root of 5 and positive square root of 5, they cancel out, so that's great. And we're left with minus 5. We can simplify that even more, right? 1 minus 5, we know that. So that's negative 4. I'm trying to see here. Oh, this should have been a 4 right here. Well, actually, this will be a great case. Now I'm seeing that we had that negative 4. I didn't realize that would happen. I'm actually going to backtrack a little bit and leave this alone because I see this will cancel out nicely if I just left this alone. Sorry for the backtrack. Sometimes we don't see that. So I'm going to rewrite this times 4 times 1 minus square root of 5. And we see that the 4's cancel out, so that's why I put it back. And we have a negative 1 on the bottom, or it doesn't matter. 1 divided by negative 1 is negative 1. So it's negative 1 minus square root of 5. And all we're doing is, if this is negative 1 minus square root of 5, I can rewrite this as, and imagine you're just multiplying each by negative 1, right? So it'll be negative 1 times 1, which is negative 1, and negative 1 times negative square root of 5, you'll get positive square root of 5. And I like to put my positives in the front, so I'm going to rewrite this as positive square root of 5 minus 1. And in this case, this will be our final answer. So now we've simplified this expression as well. So now on the next slide, you're going to get a chance to practice a couple of examples on your own.